So I gave this presentation in October at Java 1, and I thought I'd redo the whole thing. I changed it up a little bit. I was just told I don't have an hour, but only 40 minutes. So that means I'll try to get through as much stuff as possible. I've done the presentation since several times, and there's YouTube videos of the whole thing out there. So you can, those patterns that I don't get to, you can obviously also watch them online. I know we're not at Java 1 today, we're at Topconf. When I gave the presentation at Java 1, by the way, was anybody at Java 1 by any chance? So everybody that does a presentation at Java 1 that is an Oracle employee like you have to have this safe harbor statement. And I thought I'm not an Oracle employee, but I want to start with a safe harbor statement. So I Googled and I found a safe harbor statement. So that's what it is. The oil and the money goes here and whatever. Okay, so I'm talking about performance. The stuff that I show you today can be done with pretty much any tool. Okay, I use obviously Dynatrace because that's my tool of choice. I work for this company and I'm using the free available tool, but feel free to use whatever tool you have. I took a picture of the guy who presented just before my presentation at Java 1, and he said the same thing. You can do most of these things with any available tool. If you don't have a tool, look at things like Dynatrace, App Dynamics, New Relic, JProfile, or whatever. There's a lot of stuff out there. Here's one thing though that I want to say. Not here, but here is the door in case you think this talk is about optimizing your method execution times from 0.02 milliseconds to 0.01. I'm not going to tell you how you optimize your bytecode instrument, your individual bytecode lines. That's not what this is about. When I do performance analysis, I look at larger trends. I look at I could actually call them architectural metrics. I look at things like, hey, over time, at this particular point in moment, when we have more load, we could see a certain area of the application, we call this a layer, showed a significant performance impact in this case. Red, I think in this case, was database access. So we layer the application and try to figure out where's most of the time spent. I also correlated with other things. The load, was it load related, yes or no? And it seems the load was actually flat, but response time went up. Here, I'm looking at the number of database statements. And I see at the same time when the response time went up in the JDBC layer, or whatever database layer you have. At the same time, we have an increase in the number of database statements executed. So this immediately tells me it's not load related. It has something to do with we're executing a lot more database statements. Maybe somebody executed a report that is going off like crazy. So these are the things that I try to figure out first, to figure out where do I look next. But I don't start a profiler right away to figure out, oh, this method needs to be optimized by 1 millisecond. This doesn't make sense for me. Also, this is why I asked the question who you are, front and back end developers. If we look at our beautiful applications, we typically look at it from the front, and we have a beautiful front end, a beautiful mermaid, but a big beast in the end. I know some of you said you're just back-end developers, but I want to start with the front end because I want to give you some examples just to refresh the memory maybe of most of you. I think the reason why I'm here, also to give you a little bit of background about me, in the last 15 plus years, I continuously worked in performance. I started with a company called Segway Software. We created load and performance testing tools. I have some former colleagues of mine here. Segway became Borland, so I did that for 8 years, breaking applications with our load testing tools. Then I joined Dynatrace to not only break apps, but actually try to figure out why they break. So sitting in the app and trying to figure out, oh, it's this database statement, it's this bad method that is having synchronization issues. Dynatrace became CompuWare because we got acquired, but soon after, we are back to Dynatrace, and that's kind of my circle of life. And as you can see, I wear it with pride. I love Dynatrace. I think it's an awesome company. We are hiring as well, and we also have a great product, and all the stuff I show you today is completely for free for every developer and tester if you want to use it on your local machine. So everything I show you, you can do it tonight or whenever you want to work. So I have a lot of stories that I collected over the years. Most of these stories come from different places around the world. These are the spots I've visited the last 12 months. So I get to travel a lot, which is part of the cool job that I have with Dynatrace. So I did a lot of meetups, user groups, conferences, and all that stuff. So I meet a lot of people. That's why most of my stories really come from real life. So people come to me and say, I have this app and I have no clue what's going on, so please help me, and I'm not a performance expert. So I help them there. I also, what I do, I offer so-called online performance clinics. Every second week, I have an online tutorial that I record, and people can sign in and then ask questions, but I basically show how I analyze certain problems, and I also put it up on YouTube, so I have my own YouTube channel. Also what I do, I offer a service that is called Share Your Pure Path. So people that use our product, the free product or the commercial one, can send me their data and I analyze it for them. And I send them back my analysis. So it's a win-win situation for them, but also for me because I have new stories. And this is how it looks like. So when they send me data, they get a PowerPoint and I basically say, this is all of your stuff. So I send them screenshots, I give them an overview of what I found, bad database statements, there's a binary tree controller that has an issue, and I show them how I analyze the whole thing. So it's a win-win situation. What's interesting is, since I have this program and also all the other years before, I can see that about 80% of the problems that I see, and I'm sure this would be true if I look at your apps, are only caused by 20% of problem patterns. So 80% of the problems are only caused by a small number of always the same reoccurring things. And that's good for me because if I figure out now how to fast and best look at these and identify them, I can teach you, and hopefully you will start not making the same mistakes. I'm a big fan of metrics. Therefore, you will learn a lot of metrics from me, and I'm a metrics-driven person because the first thing I do, I try to look at the right metrics that tell me the problem is here, here, or here. And I can tell Christian, oh, you didn't make it was your problem, or maybe Sebastian, no, another Christian, damn it. Okay, the two Christians in the front row. Okay, quickly, front end. I want to quickly run through it. It might just be a refresher. The problem that I see, our web pages get bigger and bigger. I think we're getting fatter. That's the problem. I always look at HTTP Archive. In case you don't know, it's a great source of resources. Every day, they are analyzing the top 1 million websites in the world and then give us statistics on how many JavaScript files are on an average page. How big are these pages? So we can see a very interesting trend. Not only that, I can also look at things like, hey, what's the average number of DOM elements on a page out there? Average DOM depth, connections per page, cache lifetime setting. This gives me a little overview how the world is doing. So a lot of interesting statistics. In the real life, I sometimes see bad mistakes like this. So this is a guy, he came to me and he's operating knockoutcasino.com. It's an online casino. This is real. He came to me and said, we are constantly having performance problems on our app, and I constantly get a new build, and then I'm the operations guy that basically has to keep this thing alive. And as you can see, I always look at metrics. So I'm basically either using the built-in browser diagnostic tools. So for those of you that are web developers, I hope you know, magic tool is the finger, and then the magic key is F12. If you hit F12 in your browser, you get a cool little widget on the bottom, and it tells you how heavy is the page, how many objects. So this was almost 10 megabytes to load that page, 282 objects. That's images, JavaScript files, CSS files. The waterfall diagram here shows me that about 95% of all the content is delivered from their own server. That's mainly images. This is this color. And they had one very poor attempt to use a CDN, a content delivery network. So this Knockout Casino, their target market is Europe. And the developers decided, let's use a CDN that chose the cheapest option that they could find. Unfortunately, that service did not have any servers in Europe, but these servers were in Asia. So in order to download a 20 kilobyte CSS file, I had to spend 1.8 seconds to simply get a physical connection. Okay, so these are simple, basic mistakes. And if you have been doing web development, and this is new, then please read up on web performance optimizations and all the tools that are there embedded in your browser. Another example, these are the two key metrics, the total size and the number of resources from Pepsi.com during the Super Bowl last year. Super Bowl is coming up again this Sunday. So if you went to Pepsi.com on Super Bowl Sunday last year, and by the way, this is for the mobile page, so mobile landing page, you had to download 20 megabytes of images, and it was a total of 434. The reason why they ended up with this, they had a great idea. They said, we want everybody to take selfies of the Super Bowl parties, then send it up to our server, so we can show a 20 by 20 grid of the last 400 uploads of selfies. It's a great idea, but unfortunately, they forced my poor iPhone that I tried to use to download every single image individually and in the full resolution, resulting in 20 megabytes, and then my poor processor had to scale the whole thing down took 2 minutes to display that page. Doesn't make sense, okay? So basic mistakes. Other examples, the mobile landing page of FIFA last year at the World Cup, it was 2 years ago already, 2 years ago, 1.5 years. The biggest icon was the fav icon, the biggest image, with 370 kilobytes. The fav icon is the little icon on the top left of your browser, or if you pin the URL on your home screen of your mobile phone, it's typically a couple of bytes big. But somebody chose to use the high-resolution FIFA logo and just convert it into an icon. Okay, it doesn't make sense. I speak at a lot of conferences. This was one that I spoke at last September in Boston. And they were actually using WordPress as their conference website. When you went to the website, you have a beautiful picture of Boston. Unfortunately, that image was 8.5 megabytes big. So everybody that went on the conference homepage had to first download an 8.5 megabyte image. This is also not good. This was true for the regular app and the mobile version of it. And the reason why I'm saying this, if you build any software where you allow somebody that is not familiar with these things to upload content and you show it in the same thing. So if you have a load up an image feature, you may want to put something into the product that says, let's compress it. And let's provide a very small image for my iPhone, a medium for the tablet, and a bigger one for the real screen. And then maybe figure out, depending on the connection speed that you have, which resolution you use. Okay? So these are things you should not do. F12 is your friend. So if you hit F12 in Chrome, in Safari, in any browser, even Internet Explorer these days, you get a little thing here, the browser development tools, you click on network, and then you see all these numbers, okay? So Pepsi is still bloated. Let's see how they do next Sunday. You can also compare yourself against others if you don't really know, am I doing good or bad? There's online services where you can compare yourself with somebody else. You can enter 2 URLs, yours and the one from your competition, and then you do the online comparison. This is a service that we as Dynatrace provide, but I know Google is now also offering. It's called Google Insights Online. Just Google Insights Online, you'll find it. And then you can compare yourself. Make sense? Am I good with speed? I need to speed up because I only have 40 minutes, okay? So, I love metrics. So I look at the number of resources on a page, the size of individual resources, and the total size of page content. You can do it with whatever tools you want. We provide tools for that. You can use browser extensions also, just as YSlow and page speed. All the other stuff that is here. Okay, slides will be up there later. Last thing on front end. If you build the best and most beautiful website and you test it and everything is fine, but then you deploy it and it happens like this here, Pepsi. If you go to Pepsi.com today and you go to the Austrian store and say, show me the products, you get a message, oh, certificate has a problem, so it doesn't help you, right? So you deploy it and something is wrong. So what I'm always also proposing, not only don't stop looking at performance and availability, don't stop it before you deploy it. You need to monitor how your website is doing out there. That's why we have things like synthetic monitoring to figure out how is the website doing. If you have a website that's 100% available, you deploy a change, and then it goes down to 0, nobody sees your new beautiful features. Right? This is an example where we looked a little closer. So this is actually also from Pepsi. If we look closer at what actually happened with Pepsi, they were using Amazon's EC2 as a content delivery network. And remember, they had so many images on that page. They had 400 images. The problem is they didn't pay Amazon enough for all the cache hits. So what came back were a lot of HTTP 500s, please slow down, and the details say, please reduce your request rate. So they were choosing a CDN, but because so many people basically went to the site and everybody had to download 400 images, there was a total of, I don't know how many millions, they didn't pay Amazon enough money. That's not very good. Yeah. If your website is depending on some third-party services, then there's a good tip from my side. If you have multiple options, so for instance, if you want to integrate with a Google Maps or with some other mapping tool, and you have multiple options, then you can figure out, hey, is it down right now? You can actually figure out how often are certain services down. Because if you have multiple options, you want to choose the one that is most of the time online and not always offline because they're failing all the time. So you do your homework. So is it down right now? Another one, this is outage analyzer. This is data that we provide. So we monitor a lot of applications and websites out there, and we provide this data in this dashboard. So you can say which Amazon site was down at which particular point in time. How did the Facebook outage impact some other regions? So outageanalyzer.com. So it's a good service. Last thing on front end. This is a graph now that we also always look at when monitoring websites. It shows response time. And it's a very interesting response time graph, which is from a company called GoDaddy. GoDaddy is an online hosting company. They are doing mainly business in the US, but also in some European countries. They had a response time of about, I would say, 1.5 and 2.5 seconds. This was also on Super Bowl Sunday. 1 hour before the Super Bowl, something magic happened. The website became 4 times faster. Okay, magic. When I looked at this, I thought probably they already crashed, and the only thing they show is like a funny, we'll come back later. That's what I thought. Okay. Does anybody want to take a guess? Maybe that could be an option. Yeah. That's a very good. They used Dynatrace. So what they said, if we are spending millions of dollars to promote our website during Super Bowl, we want to make sure that we're not crashing. So they could have put more money in Amazon to buy more compute resources, or what they said, we are just reducing the message on our website to the bare minimum. We don't need everybody to know how many friends like us on Facebook, what's going on Twitter. We don't need to use the dynamic version of the Google Maps, we just use a static map. So they basically implemented a bare minimum version of the website for these 4 or 5 hours during the Super Bowl. They were 100% available, 4 times faster than anybody else, and they told the people what they wanted to tell them. So if you have some peak periods, think about how you can basically minimize the stuff, the complexity of a website. Okay, so yeah, 1 hour after the game, they flipped the switch. They basically just flipped the switch and redirect the people in that period to a more static version of the website. So key metrics, I'm looking at HTTP 300s, 400s, 500s, the number of domains, how complex is my website. Okay? And yeah, a lot of online services that you can use for doing synthetic monitoring. I think the best is if you don't do any synthetic monitoring right now, or what we also call real user monitoring, then look at some of these products or just Google for it. Good. So now I need to take a quick sip. Backend performance. The Usual Suspects. Awesome movie, by the way, in case you haven't seen it. So I told you I do a lot of these performance clinics. So I talk with people, they come to me with their problem. The first problem was reported to me, it was last year in Denver. And this guy comes to me from a very large telecom company in Britain. I guess it's very easy to connect the dots. So what he's the operator. He's actually responsible for the database that they run on an application that they use for online room reservations. So if you are working for that company, you can go online and say, I need a meeting room in that location, and you get a list of 5, 10 meeting rooms, and you say, I need this at 1 o'clock in the afternoon, like what we now do with Outlook or whatever you use. So he said, this project, this software has initially been developed 10 years ago by an intern, by somebody that did basically some work in the holidays. And it was implemented for 1 location only. Now, 10 years later, this guy is no longer there, of course. But now this software is used globally for the whole organization. Okay? Could be cool if it works. So here's the problem. The symptoms that they had, now, in order to make a room reservation, they have to wait between 60 and 120 seconds. They see very high garbage collection time on the Tomcats. Right, this was the symptoms. The developers that took over the project, so right, obviously this guy left, so somebody inherited the good or bad crappy code. And I'm sure you also inherit a lot of code over the years, and you're now responsible for it. So they said, well, probably it's bad garbage collection tuning, clear. Or it has to be the database, because they looked at the code and rendering of that data set is so simple. It has to be the database. So basically it resulted in 2 years of finger pointing between the DBA and the dev. And the DBA came to me, Joe was his name, and he said, I'm frustrated because what the developers did now, and I know we're all developers, but still what they did, they went into the code, and this is now simplified, but they had a room reservation method that produced a report for a certain office. This was the loading data for office method, the core method that loaded the data, and they basically just said timestamp here, and then log it out. To prove their point, it has to be in here and not in generating the report. And they were right. Based on their numbers, they said 45 seconds on average is spent in loading the data. Okay? So basically it's clear. So now Christian, I take you. You are Joe, the database guy, and I said, this is not my problem. It's your problem, the database. But what Christian tells me, if I look at my database tools, I see that on average, every single SQL query I see is executing faster than 1 millisecond, so I cannot optimize anything. And instead of showing you more slides, I just want to show you the data that we captured live, because I think this is, and hopefully the live demo works, but I'm sure it will. So what Joe did, he installed Dynatrace on his system, and basically what he sent me is, so what he did, Joe is a database guy. He has no clue about Tomcat. He has no clue about Apache. But what I told him, hey, you know, it's so simple. The only thing you need to do, if you have a Tomcat, I know this might be hard to see, but the only thing you need to do in Tomcat is add this parameter. This is the same for other JVMs. For Apache, you just need to load a module, and that's all you need to do. And then just run this. Oops, where is it? Where is my tick? Here we go. Hello, where is my client? Here we go. So then we basically analyzed data, and Dynatrace is then automatically capturing data from the end users that are using obviously a browser. These requests go to Apache, go to multiple Tomcat instances. So they had it clustered here, 2 Tomcat instances. They were making calls to SQL Server, to Sybase, and they had another backend service. So this is kind of the overview. He shared a total of 26 requests with me, and then to show you what this looks like, because what we did, we analyzed every line here is what we call a pure path. So this is what we record in the app while it's under full load, and I'm just picking one here, and I think I already told you a little bit how to read that graph. So this is not a single request from the real system coming in, going to Apache. Apache forwards the request to Tomcat. Tomcat makes several calls to the database, and that's the database. So if you look at this graph, can anybody spot a number that looks a little odd? 24,889. And we have a winner, exactly. So the problem was that in order to generate that report that showed 5 or 10 rooms, the software, the code, went to the database 24,889 times. And we can move the mouse over, and then we looked at the database calls. And basically what we saw was something very interesting. I want to quickly scroll down here because there's some confidential information that I don't want to share. But basically what we saw is a very clear pattern, the same database statement being called all over again with just a different ID. So this is the classical n+1 query problem. So I'm somewhere here's a select statement, give me the IDs of all the rooms, and then for every room, give me all the details. And basically, this was done 12,889 times. Plus, and let me just quickly scroll up here, because the scary part was actually somewhere here, but I'm just making this a little smaller that you don't see the confidential information. The first thing here is a call called set client name. This is a Sybase database, and I had no clue about this. If you take out a JDBC connection from a connection pool on Sybase, it will always call set client name, the security context. So that means this is the fact that they were actually getting 12,444 connections out of the pool, executing a single statement on all of them, and then putting them back. So this was basically what was really happening. And this is, can do better, okay? What we can also do here to figure out what actually really happened, we can analyze down to the method level where code is actually been executed. We saw a lot of garbage collection time. The orange means 23% of the time was actually spent in garbage collection. We saw the JDBC already. And I think the most interesting part is this here. Where's all the CPU spent? We saw that the topmost contributor of CPU was hash table get. So Dynatrace identifies that, and then on the bottom here, we basically have the reverse call stack. So who is calling hash table get? Because hash tables in general are not a bad thing. But what we basically figured out that the initial developer of the whole thing basically created his own entity framework. Okay, he created his own entity objects, and I think they had a room object in there. But the database was a hash table that was always filled with the whole content of the database. So that means every time when I open up the report, he went off and queried every single line in the database with a single statement, filled up his hash table, and then on top he had an OR mapper or an interface to get these things. Yeah? And this worked well when he started 10 years ago because they had 5 rooms in the database. Now they have 10,000 rooms in the database or even more. So even though typically when I show this, people say, it doesn't happen to me, this is stupid, right? This is basics. But believe me or not, I am pretty sure sometimes you make basic mistakes, but the scary thing is that you may have inherited code that you don't really know what the code is doing. You inherited somebody's bad mistakes. And you may use frameworks that you think you know what they're doing, but maybe you don't really know what they're doing. So going back forward, this is basically what I showed him. So when we sat down, I basically created this PowerPoint for him and said, this is what you show your developers. That's the full proof that it's their fault. I showed him all of this, right? This is the stuff we just saw. Just proof that it's not his problem, because even within the application, we could see that on average, every database statement was really just taking 1 millisecond. Okay, and this is just the stuff we saw. But just to see what you get. So, lessons learned, don't assume you know what the code is doing, you're responsible for. Don't assume you're not making the same mistakes, and just use the tools. So for database things, for database activity, if you're using Hibernate or Spring or any other tools, you know there's options where you can turn on and see log outputs. What is Hibernate really executing? Same is true for any OR mapper, I would say. You can look at JMix counters, performance counters, or look at some of the APM tools or tracing tools that are listed here. For me, the key thing is every time when I analyze an application, I look at things like how many database calls do we have? Is the same statement executed more than once? That's a clear n+1 query problem. How many connections do we take out of the pool? How many rows do we retrieve? How much data is transferred? Because sometimes we just make very basic mistakes because we are rushed or do something bad. Okay, make sense? Good. The next big favorite topic of everybody is microservices. And I have the problem that I have with microservices is that people think they can migrate to microservices. They think they can just take an existing app and they do microservices and then everything will be fine because we can now scale endlessly up and down. The gentleman from Sweden that I talked to today, where is he? Here we go. This is the website. Do you know them? No. Okay, so example from Sweden, I sat down with this guy. What this website is doing, they are listing every single sports club in Sweden. Every single verein, every single sports club. And you can go online and you can say, I need to know all the football clubs in Stockholm, for instance, because I want to send my kid to one of them. Makes sense, right? It's a good service. This service became very popular. So what they had a monolithic app. They had an app where you can see the transaction flow again. It took about, when it became popular, about 2.68 seconds on average to load the result. And what they also had the problem that it was very CPU bound. So all of the time was spent on CPU, and because it was a monolithic app, they couldn't really scale endlessly. They could only throw so much hardware on the problem. So what they said, we have a service approach. That means we're creating a front-end component that is taking care of rendering the website. We can potentially move it to the cloud, to different Amazon regions, because they now are not only operating in Sweden, but also worldwide. And the backend service is something we can host on our own data center, and we can scale it up and down using container technology or whatever we want. So this is what they did, and what the backend service team also did. They said, we want to make sure that this really scales. So we are testing the shit out of this. So what they said, we are simulating a typical workload during the day. So at 7 a.m. in the morning, we simulate small to medium loads, so we may need 2 processes to support the whole thing. At noon, there's a lot of people coming in that are on lunch break, so we need to scale out. So they basically tested all of this, and at the end of the day, they were testing how does the system behave if we're scaling down. Everything worked kind of perfectly. This is what they tested. They said, let's go live. So when they went live on the first day at 7 a.m. in the morning, this is now the data that they got from the real user monitoring. They saw the major markets, Europe and also and the US, everybody was green. People were kind of happy. Response time 2.8 seconds. At noon, when the real traffic came in, pretty much the whole world experienced very bad user experience, like 25 seconds of average response time, people frustrated, and bounce rate went up like crazy. Bouncing means people went to the homepage and then didn't do anything because everything was slow. What went wrong? What went wrong is that they never looked at the full end-to-end use case. They only tested this component, this new service. But if they would have done a single test where they tested what is really going on if somebody executes a search here, and it's, for instance, and this is the use case we tested then, search for the football clubs in Stockholm. There's 33 football clubs, okay? So if I enter that search, here's what happens. First of all, it takes 26 seconds to load. The front end is making still a direct connection to the back end. So the separation, what they did, they just carved out a class here, put it into a service, but they still had some logic in the rendering where it actually said, please database, give me the unique primary keys of those sports clubs that meet that criteria. So that means these 6 select statements return the list of 33 elements. And then for every single sports club, they made a microservice call. This is the same n+1 query problem we saw before with the database, but now it is between 2 services, which means there were every call returned 3 kilobytes of data, the whole information of the sports club, so a total of 99 kilobytes. At the end, they only needed 5 kilobytes because they were only interested in 2 or 3 elements, name of the club and the address. And they also ended up with a total of 171 database statements. So 171 plus 6, 177 actually. And by looking at these metrics, if they would have done this in development, this problem would have never made it into production. Because you just need to see that, well, I'm having a service here, but I'm using it in the wrong way. So their solution, the solution was, they understood that we have to re-architect versus migrate. So if you really do microservices, you need to understand which service interface do I need to provide here. You need to provide, give me exactly the stuff that I need, and not just give me the individual one. So they fixed the whole thing, and are now back to 2.5 seconds, 1 service call here, only 3 database calls. So that's a totally different game. If you are going to services, please understand your end-to-end use case. And I think this is also the stuff that they learned. Their aha moment that they had is, first of all, to quote the CEO of Amazon, you build it, you run it. The developers that developed the individual feature, they just said, we're done, we implemented this service, we tested it, and we're off the hook because everything works in my service. But they were not doing the full end-to-end testing. And I think the biggest one is you also measure it from dev to ops. And here is what they're doing now. First of all, I want to show it to you. How much time do we have, by the way?
5 minutes right.
So here's what they do. They have a pipeline, which hopefully most of you have a pipeline. You have a Jenkins, Bamboo, whatever you have. And what they're doing now, they have end-to-end test cases. So they have 2 major features that they're currently focusing on, a news alert and a search. They're using JMeter or whatever tool to execute these calls. When they tell them, okay, the functional test, that's already good, but what they now also do is they look at how many API calls does it really include internally? How many database statements do we have? What's the payload and what's the CPU usage? Because these numbers, if you have them per end-to-end use case, it's very cool and easy if you do a code review, an architecture review. You don't need to go through every single line anymore, but you can say, like Christian, show me your end-to-end, show me your test and your metrics for your end-to-end use case. And then we can sit down and say, well, this makes sense. What they also do, after they deployed it into ops, they also figure out on how many instances does this service actually run, what's the usage. So we only have 0.5% of all of our users that use the news alert feature. Maybe it's because we have a very crappy performance, 7.2 seconds in response time. So maybe we can fix this. Also, only 63% use our core feature, which is the search. Maybe it's also because it's very slow. So what they did, and this was basically before they did the re-architecturing, they said, let's do re-architecture and let's do the performance fixes. So they got a build later on, let's say build 25, same 2 tests. And here's the magic. If you have these tests, and these tests look at the same metrics that I showed you before in an automated way, you can say, wow, well, okay, this is a performance improvement, this makes sense, this is good, but this is no way, this is nothing we want to push forward. We now have 34 calls total, we have 171 SQL statements and all that stuff. So we're never deploying this into production. You can bake this into your pipeline and basically make Bamboo or Jenkins or whatever you use stop the build. So hopefully we can then go back and fix the whole thing so that we get back to something that makes more sense. 2 service calls, one in the front comes in, one in the back that goes out, okay? So this makes more sense, and then you can deploy it, and again, you want to monitor, cool, well, this is now running on 5 instances because we have a service-oriented architecture with multiple instances where it runs on. Performance is down to 2.5%, that's awesome, 2.5 seconds. We have an improve of usage, that's awesome. But guess what? Even though we improved the news alert, this feature dropped even more in usage. And this allows them to do another thing, which I think most of us are very bad in. It allows them to take out features that nobody needs. If you, Christian, if we implement a feature, because our product managers tell us to do it, and 3 months down the road, we figure out only 0.2% of all of our users are using it, I think we should do the following. We just take it out. We take out the code that nobody really needs. We take out the test cases. That means less complexity in your code and in your test coverage, or in the test that you need to maintain. Does it make sense? So monitoring. Technical metrics, I call them architectural metrics, which eventually end up in performance metrics, and usage. And this is your feedback loop. So this was an Excel file, Excel spreadsheet, obviously. This is how it looks like in our product. So we analyze every single test that you execute, whether it's a JUnit, an NUnit, a JMeter script. We look at every test. We look at all of these metrics that I told you about, number of database statements, number of time I called into Hibernate's query impl. And then from build to build to build to build, we look at this metric and basically learn how does this metric, for instance, the DB count, evolve over time. We baseline, and if you make a change from here to here, from this build to this build, and the number goes up like crazy, we say functionally good, performance-wise bad, or architectural-wise bad. And we can then break the build. This is the idea. So this would be in CI, and this is how you can do it in Ops. So what they do in Ops now, they are monitoring the usage of every service, and they figure out how many database statements are executed per search. How many REST calls internally do they have if a search is executed? And also what's the payload? And here's an interesting thing. So they made a deployment about here, and then they could see that there's a huge number now of these API calls that are now executing many more REST calls. So the color coding, what they do, they put the calls into buckets. They say we have 1,000 calls coming in, 100 of them are executing, let's say, 1 service call, but the rest is executing 5 service calls. So they're bucketizing it. It's like a heat map, what they have. Couple more minutes. 2 Minuten. Regular, okay. So this was an example. I have another example, a job search. I don't want to call the name, but basically they also had a job search. We lost the first one. Sorry to see you leave. So same thing, Tomcat. And what's interesting here, they were spawning, for every request that came in, they were spawning 38 background threads. Why 38 background threads? Because they were calling 38 external service calls in parallel, and they were basically waiting on all of them. Same thing, they extracted something that used to be a local method call and basically say, give me the results of this, of this, of this. They were just spawning 38 background threads. That means every single request that came in was basically blocking 39 threads. The one that came in that handled the initial request, and then the 38 that were doing all of these calls. Yeah, but you can see same problems all over. One more, oops, a more extreme one, 21,000 calls to Oracle, 3,100 calls to H2, a lot of database exceptions. So these are all examples of migration projects from monolith to microservices gone wrong. The metrics that I'm looking at is, again, number of service calls, the payload involved threads is the same service called multiple times. So it's basically not the n+1 query problem in the database, but now on the service-to-service level. Tooling, all the tools, you can find them. And now before I go to the next one, I can obviously, well, if you give me 5 more minutes, is that okay? Because I love this one here, not only because this is a cute or an angle we can log this. I know we have Splunk and we have the elk stack, and we can analyze trillions of log messages every second if you want to. But the problem is, what if logging becomes your hotspot? So here's another example of a Spring framework used incorrectly. So in this case, I think you've seen this before. So this is our hotspot view. So we looked at what are the hotspot methods. And on the very top, or the second entry, was call appenders, spending a lot of time. And here you can actually see where do these calls come from. And it turned out that they just had the Spring framework turned on to verbose logging, deployed that change into production, blew the whole thing up. Just forgot that it's not a good idea to use all the same logging options in production. Another example, again, log4j, another call appender, spending most of the time actually in sync. So this was an old version of log4j that they used, and a debug log level that they've turned on, and basically they just brought the whole Tomcat server down because they were just syncing each other to call to write these things to the log file. So what I'm always looking at is the number of log entries. So if you develop your code and if you hopefully have your tests, please find out how many log statements do we actually generate. Or we generate 2 and they actually make sense, good. We actually create 500 and I only need 1, then maybe you want to go back and figure out what you can do about it. I typically tell this to testers. I talk with a lot of testers and I tell them, if you create a test and if you test a feature, at the end, take the log files and show it to your developers. And they should mark the log lines that actually make sense. And those that don't make sense, they should figure out how to get rid of them or put them into a different log level. Okay? Good. Knowing that we have timing issues, I have a lot of more examples. If somebody, how should we do this? Are there questions so far? Otherwise, I go on. I can go on as long as people are starting leaving. Any questions so far? Okay. Shall I do one more example? Go for it. Okay. I'm a big fan of Game of Thrones, and I'm sure most of you have seen it because I think it's very popular in our age group. And I'm not picking about the older gentlemen here, sorry. So here's the thing. Sorry. Here's a deployment. Here's an interesting thing. This was a deployment. Actually, we're looking at a time frame of 2 days, and this was noon when a deployment happened. The top graph shows response time and the bottom load. So that means there was load coming in. The deployment happened here. Obviously, when you do a deployment, you have to recycle your web servers and app servers. Therefore, some requests are just blocked for a short time. That's why here you have to execute a little more load. But basically, the load was kind of the same before and after, and also the response time before and after was kind of the same, right? So if I look at just response time, I would say this was a perfectly well done deployment. Everything is good. But if I look at things like CPU consumption and memory usage, then I see a total different picture. So that means whatever change that was deployed here in this app cost my containers, my virtual machines, or maybe the resources I buy on Amazon to spend 4 times as much CPU, and also 20, well, and the root cause was probably the additional memory usage and the garbage collector kicked in all the time. So what I want to say here is not only look at response time when it comes to performance, but also how many resources you consume, whether it's CPU, memory, stuff that you log to the file system, accessing to the database. So these are all critical components. This was actually taken, and sorry for that, from a .NET application, but I see the same thing also with Java, which basically what they did, they figured out, more objects being allocated in the different generations. In Java, translates obviously to the heap spaces. More time spent in garbage collection. That explained the additional CPU. Now the problem that they had is what they figured out. They did memory dumps before and after, and they figured out they used the dependency injection library, and they upgraded the dependency injection library to a version that just injected a little more than it should inject, and therefore the regular footprint of the controller objects that were generated increased quite dramatically. So before the deployment, they had 41 controller objects with an average size of 20 kilobytes. Afterwards, they had six times larger object size and twice as many objects on the heap for the same load. And this was all because of a upgrade of the injection library. The only problem that they had, they never looked at memory. They never looked at CPU. And their release cycle was 2 months. So what they had to do, they had to go back in time and basically reran tests for their major milestone builds to find the one build where they saw a difference in behavior, and then had to narrow it down what was the change. So it took them 2 additional weeks of testing to figure out which change actually caused the problem. So what they do now, they always look at memory consumption, CPU utilization that is caused by GC, but basically memory consumption, how many objects are on the heap. And I don't want to go through this because I have a whole YouTube tutorial on how to analyze memory issues in Java and also in .NET. But in case, I'm sure most of you will struggle with some type of memory-related issue, all of these metrics are available through JMX, and there's tools out there that can automatically visualize it and pinpoint it to the problem, and use your profiling tools or use a tool like Dynatrace or all the others that I mentioned. It's all up to you. Okay? And the last metrics, and then I'll really let you go because now people are really leaving. If you remember my example from before with the pipeline with the metrics, you may also want to look at how many objects do we have on each generation. So after you run a test, you can see now, let's figure out how many objects of a certain instance are on the heap. Let's run a GC and let's see how many objects are still on there and we're not cleaned. So some of the metrics I'm looking at. All right, and I leave you now with the tips and tricks. The only thing is the last slide that contains all the links to my, where is my mouse? There we go. In case you want to know more, the slides will be up on my SlideShare, and even more, I have a lot of these talks with different problem patterns. You can get Dynatrace for free, as I said. All the stuff I showed you is for free forever for you as a developer. I have a YouTube channel where I analyze things. Contact me if you want to follow me, but don't stalk me. And read more on the blog. And we have a booth out there where we have both Dynatrace and also Ruxit. Ruxit is our new monitoring product, especially for high-scale, very dynamic applications in production. You can see a cool demo. You can also see a demo of Dynatrace if you want to. And yeah, we're hiring, I think. So we're over in Dornach. But I guess everybody's hiring in the industry. But cool. Any questions? Okay. Then, thank you.